ranges. Threats from altered freshwater and marine ecosystems, ocean predation, disease, bycatch, and food supply imbalances are contributing to diminished runs of smaller, younger maturing salmon, reducing productivity and increasing uncertainty for indigenous communities who have relied on these fisheries for millennia. Much like the ocean, heat waves play a critical climate role by limiting the amount of carbon entering and warming the atmosphere. In Greenland, an ambitious restoration and rewild effort has revitalized trend and mind movements along the ecosystem and traditional cultures they support, offering a promising model for some of Earth's most valuable environments that store critical amounts of carbon. Far-reaching and long-lasting environmental, biological, and cultural shifts are accelerating the Arctic as a result of human-caused climate change. Successes such as those in Finland demonstrate that with determined effort, we can restore ecosystems and positively affect outcomes in the Arctic and beyond.
Thank you so much for that video and the introduction, Rick. We're going to introduce Rick Thoman now to start the panelists off. He's from the International Arctic Research Center at the University of Alaska, Fairbanks.
Right.
You might want to go to the podium for that, but you can sit there if you want to.
I'm happy to go to the podium. Will my clicker work from there?
We hope it will work. We're sorry, we had a computer reset this morning. If it does not work, let us know and we will advance for you.
So we think I can click. Hey, look at that. All right. Technology rules. Well, thank you, Liza, and good morning. I'm Rick Thoman with the University of Alaska Fairbanks. And on behalf of the Arctic Report Card editors, Matthew Druckenmiller, Twyla Moon, myself, and the Report Card's coordinating editor, Sarah Tucker, I first wish to express our gratitude to the work of the many contributors to this year's report. I also want to thank the Arctic Research Program and NOAA's Global Ocean Monitoring and Observing Program for supporting the report card and the teams working to produce the outstanding graphics, the video that we just saw, and the web pages. Along with Dr. Spinrad, I'm honored to be here with three of this year's authors who will update you on specific aspects of the report card: Tom Ballinger, Daniel Schindler, and Roberta Glenn Barade. The Arctic Report Card is truly an international collaboration across borders and increasingly a collaboration across cultures, with Arctic Indigenous peoples and communities gaining a voice in the report card. This diverse perspective is essential to understand the scale and complexity of the physical, ecological changes observed across the Arctic, as well as their implication for societies within the Arctic and beyond. Each year, the report card monitors this rapidly evolving system through 8 vital signs. These are interconnected and influence each other. Collectively, they provide a view into the state of the Arctic system. We also provide less frequent updates on other parts of the Arctic system through our indicators section, and newsworthy and broader implications through the frostbite sections of our report card. And this year, we also include a sidebar on Arctic wildfire to provide a brief report on the extraordinary summer 2023 wildfire season in northern Canada. Seasonal snow cover is an important part of the Arctic environment and regulates many aspects of hydroclimate and ecosystems. And as the Arctic Report Card documents, the snow cover season is trending shorter. Snowpack in early spring 2023 was above normal in both North America and Eurasia, but then rapid snow loss resulted in record low May snow cover for the North American Arctic and near record low snow cover for the Eurasian Arctic in June. Like snow cover, the timing, presence, or absence, and thickness of Arctic sea ice are major factors in modulating the climate, the ecosystem, and human activity. Sea ice loss was slower than average at the start of the 2023 melt season, but accelerated in July. By late August, both the Northern Sea Route and Northwest Passage were open for commercial and tourist ship traffic. The September sea ice minimum of 1.6 million square miles was about 10% lower than the past 2 years, and overall the sixth lowest in the 45-year-long satellite record. The Greenland ice sheet lost mass in the past year, as it has every year since 1998. Above average snowfall of parts of the Greenland ice sheet between autumn 2022, spring 2023 contributed to a comparatively low total mass loss in spite of extensive late June to September ice melt, with the cumulative area of the summer ice melt the second highest on record. Now, the Arctic Report Card also aims to shed light on less well-known features of the Arctic environment. And this year we have an essay on subsea permafrost. Subsea permafrost exists today in Arctic regions that were exposed frozen lands during the last ice age, but were subsequently covered by rising seas. Now, it's estimated there are nearly 1 million square miles of subsea permafrost, but we lack representative observations in most areas. This scientific gap highlights the urgent need for international cooperation to better understand this facet of the Arctic system and the potential for release of greenhouse gases as it thaws. The 2023 circumpolar average peak tundra greenness was the third highest in the 24-year satellite record, slight decline from 2022, and this closely aligned with air temperatures and the timing of nearshore sea ice melt. Peak vegetation greenness in 2023 was much higher than usual in the North American tundra. You can see that dark red there in the Beaufort Sea area of North America. In contrast, the tundra greenness was relatively low in the Eurasian Arctic, particularly in north-central Siberia. Now, it's important to remember, while tundra greenness shows multi-decade increasing trend, like other parts of the Arctic environmental system, there is significant regional and year-to-year variability. The value of Indigenous knowledge to address contemporary and vital environmental problems is also highlighted in an essay on the restoration of peatlands in northern and eastern Finland. The impacts of peatland degradation in Finland have been severe, with negative influences on culture, traditional livelihoods, ecosystems, and carbon storage. The scale of successful peatland restoration, also called rewilding, demonstrates a locally important ecosystem rejuvenation and at the same time a relevant climate solution by providing carbon sinks. Now, this type of restoration requires partnership, recognition of Indigenous and community rights, and the use of Indigenous knowledge alongside Western science to succeed and to avoid repeating past inequities. And with that, I'd like to pass it off to Tom Ballinger, who will provide us with an update on this year's temperatures, precipitation, and some of the impacts. You want to come up?
Thanks, Rick. I'm Tom Ballinger, and I'm from the International Arctic Research Center at the University of Alaska Fairbanks. (2023) was the 6th warmest year on record since 1900 for surface air temperatures across land and ocean areas in the Arctic. This marks the 14th consecutive year where Arctic temperatures have been higher than the 1991 to 2020 mean, and the 8 warmest years since the dawn of the 20th century have occurred since 2016. A warm 2023 was punctuated by the warmest Arctic summer on record, with air temperatures 2.3 degrees Fahrenheit above the 1991 to 2020 mean. During this season, most of the northern high latitudes saw warmer than average temperatures, especially over Canada's Yukon Territory, Northwest Territories, Nunavut, and the Canadian archipelago. Warm anomalies of note were also found over northern Alaska, the northern portion of the Greenland ice sheet, and atop the southern Barents Sea and Caris Sea. Now I'd like to briefly discuss precipitation. This past year's warm air temperatures coincided with above average precipitation in the Arctic. Precipitation ranked as the 6th highest since 1950 and continued a trend toward wetter Pan-Arctic conditions. Moreover, higher than normal precipitation during all seasons characterized this past year. Despite these findings, distinct regional and seasonal variability in precipitation is a common feature of the warming Arctic. For example, a wet winter characterized portions of Alaska, though a dry spring was observed over Western Eurasia, and northern Canada was impacted by a dry summer. The warm, dry summer conditions across northern Canada, combined with early snowmelt, contributed to unprecedented wildfire activity. Most of the fires occurred within the Northwest Territories, where roughly 300 separate fires burned nearly 16,000 square miles, the largest area burned in the 44-year record. The societal impacts of the extreme fire activity were devastating, as nearly 2/3 of the Northwest Territories residents were evacuated through the summer. On August 13th and 14th, one of these fires destroyed the community of Enterprise. Across much of Canada, dense smoke from high latitude fire activity created poor air quality. Further west, fire activity in Canada's Yukon Territory and in Alaska were less pronounced, with observed burned areas approaching the 30-year median. The Northwest Territories' 2023 fire season serves as another striking example of increased high latitude fire extent and intensity in today's warming Arctic. Now I'd like to pass it on to Daniel Schindler, who will discuss Arctic sea surface temperatures, primary productivity, and some impacts on Western Alaska salmon stocks.
Good morning. I'm Daniel Schindler I'm on the faculty at the University of Washington. The focus of my research is on the salmon ecosystems of Western Alaska. Understanding how ecosystems respond to climate change is one of the biggest challenges for developing strategies for maintaining the resilience of Arctic ecosystems and for minimizing the impacts on people. In 2023, ocean warming continued in surface waters of most areas of the Arctic, as shown by the red colors on this map, which indicate above average temperatures. Marine ecosystems are highly influenced by warming oceans. And one important characteristic of ecological responses to climate change is that they often amplify the changes we see in the physical environment. For instance, warming sea surface temperatures in the Arctic Ocean have been associated with a 20% increase in rates of primary production, the growth rate of algae, over the last 20 years. In Western Alaska, we have a particularly clear picture of how ecosystems have responded in concert with warming oceans. The responses of Pacific salmon to warming oceans have been surprising, both in their magnitude and in their character. Chinook salmon, on the top right there, they're the largest salmon in all watersheds of Western Alaska, have shown a long-term decline that started around the year 2000. In 2022, Chinook salmon were at about 80% of their long-term average abundance since 1990. Sorry, they were 80% lower than the long-term average since 1990. Chum salmon, they're in the middle, exhibited a coordinated and abrupt collapse in both the Yukon and the Kuskokwim rivers starting in 2018, with recent abundances about 90% lower than the 30-year average. In distinct contrast, sockeye salmon, the red ones there on the bottom right, have reached unprecedented high levels of abundance over the last decade. Bristol Bay produces over half of the world's sockeye salmon, and record high abundance have occurred in the last 10 years. In 2022, commercial fisheries caught over 60 million sockeye salmon, which is almost 20 million more than the previous record, while simultaneously exceeding the management targets set for spawning populations in the watersheds. These numbers were neither predictable nor would they have been believable a decade ago. In addition to the changes in abundance of salmon returning to Western Alaska rivers, there have been distinct declines in body sizes of all species. Salmon are getting smaller. For example, Chinook salmon returning to the Yukon River are smaller and carry about 15% fewer eggs than they did historically. The mechanisms for these declines in body size appear to be a combination of warming oceans, increasing competition with hatchery-released pink and chum salmon, and size-selective predation by burgeoning marine mammals. The unanticipated changes in salmon are generating new conflicts among people who depend on salmon for their livelihoods and well-being, and distinct hardship for many salmon-dependent communities. In Bristol Bay, record high catches of sockeye salmon have glutted global markets and depressed wholesale prices to levels we have not seen in decades. Despite exceptional catches in 2023, it is not clear that many people actually made any profit in Bristol Bay sockeye fisheries last year. A distinctly different conflict is developing because severely depressed chum and Chinook salmon that are bound for Western Alaska are intercepted by commercial fisheries off the Alaska Peninsula that harvest the highly abundant sockeye salmon bound for Bristol Bay. Interceptions of chum and Chinook salmon are socially critical because these species are the mainstay for subsistence fisheries that support tribal communities throughout remote watersheds in Western Alaska. Subsistence fisheries, which typically have management priority in Alaska, have been severely restricted or completely closed on the Yukon and Kuskokwim rivers in the last 3 years. Livelihoods, nutrition, and cultures of these subsistence communities have all been heavily impacted. The management challenge is to figure out how to efficiently harvest highly abundant sockeye salmon while protecting severely depressed chum and Chinook salmon and the communities these two latter species support. Management systems that have worked in the past are being severely challenged by climate-induced changes to ecosystems. We need to ensure that we have management systems in place that are both responsive to further changes in ecosystems and that equitably share the burden of climate impacts among human communities. Thank you, and I'd like to turn the floor over to Roberta Glenn-Barade.
Thank you. Parlagifsi, uvangat turak, nalor mutun, Roberta Glenn Barade, utkervig miugurunga, inuperurunga. Akaga ikalin ukpik, apaga saviklen. Savaktunga University of Alaska Fairbanks me. Hi, everyone. My name is Roberta Turuk Glen Barade. I'm from Utkervik. I'm Inupiaq. My mom is Arlene Ikalin Ukpik, and my dad is Richard Savik Glen, and I work at the University of Alaska Fairbanks. Indigenous people have been living in the Arctic for millennia and have developed deep connections to the land and sea, laying the foundation for holistic understandings of marine, terrestrial, atmospheric, and sea ice systems. These knowledge systems reveal widespread and unprecedented changes in the Arctic. The Alaska Arctic Observatory and Knowledge Hub, or what we call AOK for short, is a long-term community-based observing program which supports sustained and holistic environmental monitoring by Inupiaq observers in coastal Arctic Alaska. AOK focuses on Nunakit Savakativ Lugich, or working with communities to provide a platform to share Indigenous knowledge, observations, and expertise in the context of a changing Arctic. Since the project began in 2006, there have been over 10,000 observations to document changes in Arctic Alaska. Inupiaq observers have noted sea ice loss, warmer air and ocean temperatures, changing wind patterns, and increased intensity and frequency of coastal storms that contribute to flooding and erosion. These environmental changes have real impacts on community infrastructure, traditional activities, and access and availability of subsistence resources. Our work is increasingly turning to our community partners to make use of these observations to support local priorities and needs. Despite these rapid changes, AOK communities are still able to go out hunting, they're still able to catch animals, and they're still able to live a lifestyle rich with cultural traditions. Yes, there are challenges, but we shouldn't be labeling Indigenous people in the Arctic as victims of climate change. We don't subscribe to this idea that we are victims of our environment. There's strength in sharing our voices, in sharing our histories, our knowledge, our concerns, and our ideas for how to move forward. And there's strength in being proud that we have survived as a people to make it this far, to be able to continually thrive in our region, living off the land and sea, and we don't plan on stopping soon. And you know, there's strength in listening. We're strong people with strong knowledge systems and strong ideas about how to move forward. And when we come together, all of us, we're able to accomplish great things. And that's a message I would like to leave with everyone here today. Thank you, and now we'll take questions. Thank you so much to our panelists. And as Roberta told us, we're going to move on to Q&A now. Just a reminder, this is for reporters in the room and online. If you are not a reporter, we'll ask you to come talk with the panelists afterwards. If you're in the room, just wave at us. We'll bring you the mic. And as you know, if you're online, put it in the Q&A box and we'll switch back and forth. We're going to start here. Please introduce yourself and your outlet.
Hi, my name is Omer Irfan. I'm a reporter at Vox. A personal question for the panel, if I may. Given, as Dr. Spinrad said, that we're at the tail end of the hottest year ever, and you work in a field of research that's observing these changes in real time, and as you see how the global response is shaping up at events like COP28, how does that make you feel seeing these things happening? And does that affect your research priorities and the way you pursue your ambitions here in science?
I'll respond to that. I mean, I think the reality is, if you look at Western Alaska, climate change is not something that's coming down the pipe somewhere in the future. It is happening now. It's been happening for decades. And whether you're talking about fish or people or birds, there are real impacts that we need to deal with right now. And when you hear about what's going on at COP22, there may be reason to be optimistic, but the reality is we need action on the ground right now not to necessarily turn around climate change immediately, but to deal with the fact that we're going to be challenged by it now and for decades to come. So we need action now at local scales.
And I'll just second what Roberta ended with, that as Alaskans, as peoples in the Arctic, we are living this change every day, and we have no choice at all other than to work with what's happening. And we need the big picture solutions, but no one in the Arctic, Indigenous communities, all the peoples of the Arctic are having to adapt right here, right now. And it didn't start today, didn't start yesterday. This has been ongoing for years. Listen to the elders. This change has been happening for decades, century scale changes. And Arctic peoples are still here, and we're still gonna be here.
Yeah, I was just gonna reiterate exactly what Rick said. It just, to me, it underscores the importance of looking to Indigenous knowledge holders and finding a path forward.
I think I saw a hand from John.
Liza, just briefly, when our panelists are answering a question, would you please identify yourselves, both for the folks online and for the folks a little bit further back in the room who can't read your tent cards? Thank you.
Thank you. Jonathan Amos, BBC. Can you explain the different responses of the different salmon types to rising temperature waters? What is it about the water temperature that they react differently to? Because obviously the sockeye seem to like it.
Yeah, Daniel Schindler, University of Washington. Question is, why do sockeye seem to be benefiting from climate change where chum and chinook are not? In the case of sockeye, they rely on big lakes for their nursery habitats. And over the last 50 years, we've documented earlier ice breakup, warmer summer temperatures, and actually increased plankton production. And it's that plankton that feeds the juvenile salmon. They're growing faster, again documented, and that's turning into higher survival rates in the ocean. In the case of chum and chinook salmon, they're more river-dependent species. Chum in particular basically wash right into the ocean, and the ocean simply hasn't been a productive place for them. The mystery about Chinook salmon remains a mystery. There's lots of different explanations. Ecologists are good at telling retrospective stories, and maybe we'll piece one together for Chinook salmon, but the reality is there's a whole bunch of different things that appear to be affecting Chinook salmon, and there's not a really coherent message for what's causing the declines, but it's a reality.
So the sockeye have a phase where they stay in lakes before they go back out. Yes, I mean that's essentially what you're saying. Yeah. Whereas the other two appear not.
Exactly. Sockeye spend 1, sometimes 2 years in lakes growing. It's a fairly protected environment, and they're becoming more productive with recent climate change.
Next question. Guys.
Hi, Barbara Moran from WBUR in Boston. I have 2 questions. The first is for Rick Spinrad. I was wondering if you could share any takeaways from COP in relation to this. What were you doing there, and anything good happen out of it? And second, it's often repeated that the Arctic is warming up to 4 times faster than the rest of the world, and there are various reasons for that. And I was just wondering what the latest sort of consensus is on how much faster it's warming than everywhere else, and what are the key reasons for that? Thanks.
Yeah, thank you. I'll be very brief on COP because I want to keep the focus on the Arctic report card and simply say, obviously, COP is still going on, so the negotiations associated with a lot of the policies, loss and damage, and those sorts of things is ongoing, and I'll reserve comment on that until we see what the final outcome of those negotiations is. However, I will add that what I was encouraged by was a couple of things. One is the role of the oceans. It was very strongly emphasized throughout, whether it's in terms of MPAs or ocean acidification or habitat restoration. The role of the oceans is critical. The role of science in general is taking a much stronger position at COP than I've ever seen before. Things like nature-based solutions are getting a lot more attention than they got before. I also think, and there's been a lot in the press about this, I think the role of the private sector and the engagement of the private sector was a very positive aspect of COP. We need to have that dialogue. So stay tuned with respect to the negotiation outcomes, but in terms of the position of geosciences writ large, earth, environmental sciences, I think we can feel good that the voice is being heard. Thank you.
Tom Ballinger, UAF. Regarding your question about the warming, the Arctic warming and the fact that it is faster than the global mean has been well documented for a while. This number of 4 times the global rate, I know has been published and commented on quite a bit in the last year, especially. Just one comment I will make in this regard, really depending on how you define the Arctic and which data sets you use, that number may fluctuate a little bit from a factor of 4 from lower latitudes. But nevertheless, we have seen this outsized warming. It has been going on, and there's this continued divergence from the global temperatures that's been striking and maintained now for upwards of a decade plus.
What are the main causes of the warming in the Arctic being faster than the rest of the global mean?
There's a number of complex processes and feedbacks going on. Some have to do with the ongoing loss of snow cover and sea ice. Some have to do with ocean warming as a result of that, warmer ocean waters being transported into the Arctic through various gates. There's a number of processes going on, and I'd be happy to talk more offline about specifics.
Thank you. Horst Rademacher, Frankfurter Allgemeine Zeitung in Germany. Just one question. You mentioned the peatland restoration in Finland. And why is that so significant, this unique or one element, the restoration at one point? Are there any other restorations going on in other peatlands in the Arctic? What's the significance of this?
Yeah, thanks. This is Rick Thoman, University of Alaska, Fairbanks International Arctic Research Center. Thanks for your question, and it's a good one. And I think the value of what's been happening in Finland is that it represents a regionally relevant solution that to both restoring an environment that has been through industrial activity severely damaged, and it's being done in a culturally informed way. So can that I think that combination can be repeated elsewhere. Obviously, the solutions and the specific problems will look different. But I was particularly happy with this essay because it allowed us to highlight a specific European response in the Arctic to this regionally specific problem. I guess so that's the answer. I guess I'm not an expert in restoration activities across the rest of the Arctic. We can certainly dig into that for you and see if we can find some other examples like that. Does that answer your question? Thank you.
We have a question online from Yerith Rosen of the Alaska Beacon. On precipitation, can you cite some extreme events that are examples of the long-term trend and further discuss?
One example that stands out was the extreme rain on snow event this past year ago, around Christmas time in Fairbanks in particular, we document a couple other examples in the report card, which I do not have in front of me, nor do I have memorized.
Sure. So in particular, this past summer in Scandinavia, extreme short-term precipitation produced flooding. Winter of 2023 saw extremely heavy precipitation in parts of Alaska as well as Eurasia. And really, it's part of this global pattern, right? Extreme precipitation is causing problems around the world. The Arctic is having its share as well. We saw examples in 2023. We're going to see more examples. That's a certainty. As atmosphere and oceans warm, more water vapor in the air, storms come along. They're gonna tap into that. Extreme precipitation events are our future.
I see you.
My name is Amy Mayer. I'm a freelancer based here in the Bay Area. Roberta, I wanted to thank you for bringing your contributions and your language to the group. I have noticed that federal funding for science in the Arctic has been increasingly seeking co-production of knowledge and participation of residents in many communities. I'm curious, from your work and experience, what is the reaction of some of the people you know in your hometown and other communities to what should be an increase in engagement? Is that happening? And what is the reaction to how scientists are maybe changing their approach?
Yeah, thank you. The reaction is positive. People are wanting and willing to share their knowledge and expertise about what's going on in their own hometowns, and they're always happy to share. And through the work that we do, we've been able to work with the AOK communities to hold some of these co-production type workshops, and we always get a strong response, especially when they know that we at AOK, we're working to elevate their perspectives, not just, within Alaska, but within the United States at the state and federal level, especially in connecting with agencies. And so there is a strong desire to be heard and listened to by the outside world. Thank you.
More questions from the audience? Wave to me. Online? Nothing online? Anyone? You want to ask questions. Okay, well, if there's no more questions in the room or online, then we'll thank our panelists for coming. And we'll thank you all for coming. Our next press conference will be at 1:30 in this room, beyond Perseverance Rover's next steps. We hope you can join us then.